All right, hi everybody. Today we are going to be doing a brief introduction to something called exponential functions. So far we've been looking at different kinds of functions, and we have had linear and quadratic. So let's remind ourselves about those just really quickly. So linear are going to be any kind of straight line. So it could be diagonal going up, it could be diagonal coming down, they could even be horizontal or vertical. Quadratics, so these were the straight lines. Quadratics were the U shape, which are called parabola. So any U shape, it could go right through the middle of our graph. It could be offset to the side, up or down, and they can even be upside down. So those are quadratics. So the one we're going to talk about today, maybe it's new to you, maybe you've seen them before. You'll definitely talk about them in biology class when you get to science. We have graphs called exponential, and we have two kinds of exponential graphs. Our first one is the exponential growth graph. An exponential growth is called growth because you are going to start out making small, tiny, incremental changes, and then all of a sudden, your graph will go up very quickly. So you can see that it's very slow right here, and then it jumps up really fast. It almost looks kind of like a ramp. Like if you were a skateboarder or a BMXer, might be using a ramp like this. And then we have a decay graph, which is kind of like the exact same thing, except instead of starting out slow and going up really fast, we are going to come down really fast and then kind of slow down. So it'll start up here, come down really fast, and then slow down. So these are both exponential growth and exponential decay graphs. So exponential growth and decay graphs kind of stem from this idea of something that's going to grow really fast or kind of die off really fast. So for growth, I always like to talk about my favorite show. That's The Walking Dead. So we're going to talk about zombies for a second. So when you have a zombie, right, there has to be a starter zombie. So you have one starter zombie. And then let's say that starter zombie bites 3 people and creates 3 new zombies. And now those 3 zombies each bite 3 people and create new zombies. And you can see that we've already gotten ourselves up to 9 zombies. And we started at 1. And then if all of those 3 bite a zombie, it's going to grow really, really fast. So that's going to be an exponential growth. Exponential decay, you'll probably talk about when you get into chemistry. Exponential decay is talked about a lot when we talk about the half-life of elements. So when we have radioactive elements, we talk about how quickly or slowly they kind of decompose, and so they're no longer radioactive. So just kind of a visual idea of that. So let's say you have this large amount of material, radioactive material. If its half-life after, let's say, 10 years, it's half as big. And then another 10 years, that's half as big. And another 10 years, that's half as big, and then half as big. You can see that it starts to jump down really fast at first because it has such a long way to go to get to half. But then as you keep jumping, because the smaller and smaller pieces, it kind of just slows down. So that's kind of what this graph here is representing. The big jumps at first, and then as you start to lose more and more of its radioactivity, it really starts to slow down. All right, so we have already talked about linear and quadratic, so we're mostly going to be focusing on exponential today, but I do want to do a lot of comparisons. So with linears, you may remember that a lot of linears can be written like this in slope-intercept form, y equals mx plus b. And what makes it linear is that the highest exponent on x is 1. So because there is no exponent here, then it's an assumed 1. There's 1x there, so it's x to the first. And in quadratics, a lot of times our equations will be like x squared plus 7. Here what makes this quadratic is that the highest exponent on x is 2. So these two actually do have something in common. We know if it's linear or exponential based on what exponent is on the x. But in exponential, we can't talk about the exponent in terms of what's the highest exponent. Literally in exponential, the exponent is the x. So anytime we have a number raised to an x, that's going to be an exponential equation. Okay, so now let's look at the actual table so we can look at an actual graph. So I'm going to use that same equation for before, y equals 2 to the x. And go ahead and grab your calculators and get those out, or open it up on your computer, wherever you're going to use it. We're going to make ourselves a table so we can take a more accurate look at this graph. So again, with any table, you can always pick whatever numbers you want. I'm going to just go -3 to 3 so we can kind of get a good picture. So I'm going to actually start here, and then we'll kind of work our way backwards. So if you go ahead and plug this into your calculator, 2 to the 0, you should get 1. Now, when we get into our exponentials chapter, we will talk about why that's equal to 1. Maybe you remember that from last year if you did some exponentials, but this is going to equal the point 0, 1. Then we're going to do 2 to the first power, and that's 2. So this will be the point 1, 2. 2 to the second power is 4. 2, 4. 2 to the third power is 8. 2, 8. So you can see that our numbers start out jumping by kind of small amounts, but then they start jumping really fast. And if I actually did 2 to the fourth, that would give me 16, and starting to jump really fast now. So what makes this exponential is that from here to here, from here to here, and from here to here, we're multiplying by 2 every single time. So if you're multiplying by the same amount every single time, that is going to be an exponential graph. All right, let's go backward for a second. Type this into your calculator. 2 to the first should spit out probably a decimal of 0.5. So that's -1, 0.5. 2 to the -2 should spit out 0.25. And 2 to the -3 is 0.125. So if we talk about here, we're multiplying by 2 every time. These are also multiplying by 2 every time, because this is like a quarter. If you multiply a quarter times 2, you get 50 cents, right? So 0.25 times 2 is 50 cents. 2 sets of 50 cents is going to give you 1. So we're always multiplying by 2, even when we're using these negative exponents. So when we go to graph this, -3, and 0.125 is pretty close to 0, so I'm going to put a point pretty close to 0. And then -2.25, it's not up much from there. -1, 1/2, again, not much up from there. 0, 1. Now is where my jumps are really going to start to be noticeable. So my next point is at 1, 2, and then 2, 4, and then 3, 9. Sorry, 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you can see as our exponents get bigger, this jump gets a lot faster. Now, even though I didn't keep going, this does just kind of flatten out. So we just kind of flattened it out here, put arrows on both ends, and you can see that it kind of looks ramp-shaped. So exponentials are going to give you that ramp shape, either going up or going down. This is just an introduction to that, so I just wanted to kind of show you what that would look like. Exponential growth. This one was exponential decay, so both are ramp-shaped. And how you can tell in a table if it's exponential is we'll be multiplying by the same amount every time. All right, if you guys have any questions, make sure you reach out. Otherwise, have a great day.